In this video, we are going to discuss terminology used related to exponents and then evaluate exponents focusing on when the base is negative. So let's start with the expression 2 to the 5. This expression is called a power and represents the repeated multiplication of the same number. So here, the 2 is called the base, and the little number 5 is called the exponent. So 2 to the 5 says that we repeat the multiplication of 2 5 times. So it's 2 times 2 times 2 times 2. And then we would evaluate that if asked by multiplying all these together. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So for each example in this table, we are going to write the expression in expanded form, and then we will evaluate. So here we have a base of -2 to the exponent 3. These brackets are very important around the -2 because the brackets tell me that I am multiplying -2 3 times. If there were no brackets around the negative and the 2, I would only multiply 2 3 times. But because the negative is inside the brackets with the 2, my base is -2, and I'm going to multiply that 3 times. So -2 times -2 is +4, and then when I multiply that by -2, I can get an answer of -8. In the next example, again, I have base of -2. This time I'm multiplying it 4 times. So -2 times -2 times -2 times -2. And as the exponent gets bigger, often it is easier to group the numbers together when you are evaluating. So -2 times -2 is +4, -2 times -2 is +4, and then multiply 4 by 4 to get +16. So when the base is negative, sometimes when we evaluate it, the answer is negative and sometimes it's positive. That will depend on the exponent. If the exponent is odd, such as 3, it will be a negative answer. If the exponent is even, such as 4, it will be a positive answer. The next example, I have -2 to the exponent 4. But the negative is not inside brackets with a 2, so that means the base is just 2. So here the base is 2, whereas above the base is -2. So that means I'm going to multiply 2 by itself 4 times, and then I'm simply just going to put the negative in front. That negative is from here, that is in front of 2 to the 4. So now I'm going to multiply 2 times 2, 2 times 2 to get 4. So I'm going to multiply 4 times 4 to get 16, but then I'm taking the negative of that. So that evaluates to be -16. So notice when the base is -2, when you have an exponent of 4, we get a positive answer. But here, when the base is simply just 2, and then we're multiplying that by negative, we get a negative answer. So the brackets are important because they tell us what the base is. In the next example, the base is -2 to the exponent 4. Again, -2 is in brackets, so that exponent only applies to what is inside the brackets. And then we're going to take that and multiply it by -1, or take the negative of that answer. So I'm going to write -2 4 times, and then I'm going to put a negative in front. So this negative comes from the negative in front. The negative inside the brackets is due to the negative base. So now when I evaluate, for -2 times -2 is +4, -2 times -2 is +4, multiply those together to get 16, and then multiply that by -1 to get negative 16. Do not be tempted to multiply these two negatives together or combine them to make a positive. That is not true because you have to follow BEDMAS. You have to follow the order of operations and apply the exponent before you multiply the two negative terms together. So you can't just combine those two negatives to a positive due to that exponent of 4. In the next example, our base is a fraction. It's 2/3. It's being cubed. So that means we're multiplying 2 over 3 times 2 over 3 times 2 over 3. And then we see that we're multiplying 3 fractions. So we're going to multiply the numerators, 2 times 2 times 2, which is 8. And then we will multiply the 3 denominators, 3 times 3 times 3, which is 27. You can also think of it as 2 cubed over 3 cubed. So the exponent on a fraction applies to the numerator as well as the denominator. In the last question, only the 2 is being cubed, and then that is being divided by 3. And again, it's because of the brackets. So the brackets, again, are important when you're dealing with fractions. So that means we are doing 2 times 2 times 2, and then taking that and dividing by 3. So the answer here is 8 over 3. So let's look at an example where we can apply these exponent laws. So here I have -1 in brackets to the exponent 35, take away -2 plus 4 in brackets all cubed. So to evaluate this expression, I need to follow the order of operations. So I notice that I have brackets and I have -2 plus 4 in the brackets. So I'm first going to simplify that and I get -1 to the 35 minus 2 cubed because -2 plus 4 is 2. And now I'm going to apply both the exponents. So -1 to the exponent 35 is actually just -1. And I know that because if I take the base of 1 and I multiply it by 1, 1 times 1 is 1. If I multiply that by 1 again, it's still 1. Multiply by 1 again, it's still 1. So no matter the exponent on 1, I will always get 1, an answer of 1. Here the base is -1, so I'm either going to have an answer of +1 or -1, and that will depend on if the exponent is odd or even. Here the exponent is odd, so that means if I'm doing odd exponent of a negative base, my answer is negative. So I have -1, and then I'm taking away 2 cubed. 2 cubed is 8, so I'm taking away 8. -1 take away 8 is -9. So far we have evaluated all of these exponents without using a calculator, but it is also important to know how to use your calculator, especially as the exponents get bigger. So grab your calculator and locate the x squared button. You are likely familiar with this button on your calculator. Your calculator may even have an x cubed button. But for dealing with higher exponents, you have to tell your calculator what exponent you want to use. So near your x squared button, there is likely another button that could say x to the y, or it could have x to an empty box, or it could even look like a hat. So see if your calculator has one of these buttons. It may not, but these are the 3 most common buttons for exponents on a calculator. So let's try an example of 3 to the power of 5. So when putting this into your calculator, enter the base, which is 3, then enter your exponent button, and then you have to tell the calculator what exponent you want. So in this case, it's 5, and your answer should be 243. Let's try it with a base of -3. So when your base is negative, you are going to have to put the base in brackets. So bracket -3 to the exponent 5, and again, the exponent is negative, so your answer is going to be negative. So it's -243.